So we have here the examples of watersheds in the Philippines. First, we have here the Ambuklao, which is located at Bukod Benguet, the Binga, Tugon Benguet, the San Roque, which is in San Miguel, Pangasinan, the Angat, which is in Norzagaray, Bulacan, the Caliraya in Lumban, Laguna, the Agus 4 in Lanao del Norte, the Lake Lanao in Lanao del Sur, the Pulangi 4 in Maramag, Bukidnon, and the Ala River in South Cotabato. Delineation of a drainage area. Watershed delineation is the process of identifying the drainage area of a point or set of points. So here's an example. And to add, for many years, civil engineers have been using United States Geological Survey or the USGS paper maps for watershed delineation. Watershed delineation and drainage area measurement. Watersheds or drainage basins are comprised of a network of stream channels that lead from smaller to larger, providing conduits for surface water runoff and sediment transport on the Earth's surface. Topographic map. A map characterized by large-scale detail and quantitative presentation of relief, usually using contour lines. So here's an example. Next is steps in delineating a drainage area. First is use a topographic map to locate the river, lake, streams, wetland, or other water bodies of interest. Next is trace the water course from its source to its mouth, including the tributaries, which is in figure 2. Here, you can see the streams, drains, swales, channels. These steps determines the general beginning and ending boundaries. Third is examine the brown lines on the topographic map that are near the water course. These are referred to as the contour lines. So you don't have the brown lines, but then the contour lines and an example point X at an elevation of 70 feet above the sea level. So basically, the contour line is a line drawn on a topographic map to indicate ground elevation or depression. Next is contour lines spaced far apart indicate that the landscape is more level and gently sloped. That is, they are flat areas. Contour lines spaced very close together indicate dramatic changes, which is rise or fall, in elevation over a short distance. That is, they are steep areas, which is in figure 4. So next is check the slope of the landscape by locating two adjacent contour lines and determine their respective elevations. The slope is calculated as the change in elevation along a straight line divided by the distance between the endpoints of that line. So here's the example. And next is determine the direction of the drainage in the area of the water body by drawing arrows perpendicular to a series of contour lines that decrease in elevation. Stormwater runoff seeks the path of least resistance as it travels downslope. The path is the shortest distance between contours, hence a perpendicular route. So here's an example. The next is mark the breakpoints surrounding the water body. The breakpoints are the highest elevation where half of the runoff would drain towards one body of water and the other half would drain towards another body of water. Next is identify the breakpoints. Connect the breakpoints with a line following the highest elevation in the area. The completed line represents the boundary of the watershed. So here's an example in the figure 9. Next is, once you've outlined the watershed boundaries on your map, imagine a drop of rain falling on the surface of the map. Imagine the water flowing down the slopes as it crosses contour lines at straight angles. Follow its path to the nearest stream that flows to the water body you are studying. Imagine this water drop starting at different points on the watershed boundaries to verify that the boundaries are correct. Step 10 is distribute copies of your watershed map to your group. Next is watershed sometimes have what are termed sub-watersheds within them. Rivers, large streams, lake, and wetland watershed often have more than one sub-watershed, usually smaller tributary watersheds. Within them, generally, the larger the water body you're examining, the more sub-watersheds you'll find. Your watershed map can be further divided into smaller section or sub-watersheds if it helps organize your study better. The final step is once the watershed and sub-watershed, which is optional, boundaries have been delineated on the map, your team can verify them in the field if necessary. Thank you.